Also, in this section, we will learn how simple file upload functions can be used as a powerful vector for a number of high severity attacks, as shown. How to also, I will show how to bypass common defense mechanisms in order to upload a web shell, enabling you to take full control of a vulnerable web server. Given how common file upload functions are, knowing how to test them properly is essential knowledge. The first question is, what are file upload vulnerabilities? File upload vulnerabilities are when a web server allows users to upload files to the file system without sufficiently validating things like their name, type, contents, or size. Failing to properly enforce restrictions on this could mean that even a basic image upload function can be used to upload arbitrary and potentially dangerous files instead. This could even include server-side script files and enable remote code execution. In some cases, the act of uploading the file is in itself enough to cause damage. Other attacks may involve a follow-up HTTP request for the file, typically to trigger its execution by the server. What is the impact of the file upload vulnerabilities? The impact of file upload vulnerabilities generally depends on two key factors. It's which aspect of the file the website fails to validate properly, whether that be its size, type, contents, and so on. What restrictions are imposed on the file once it has been successfully uploaded. In the worst case scenario, the file type isn't validated properly and that the server configuration allows certain types of file, such as PHP and GSP, to be executed as code. In this case, an attacker could potentially upload a server-side code file that functions as a web shell, effectively granting them full control over the server. If the file name isn't validated properly, this could allow an attacker to override critical files simply by uploading a file with the same name. If the server is also vulnerable to direct retroversal, this could mean attackers are even able to upload files to unanticipated locations. Failing to make sure that the size of the file falls within expected thresholds could also enable a form of denial of service attack, whereby attacker fills the available disk space. The next question is, how do file upload vulnerabilities arise? Given the fairly obvious dangers, it's rare for websites in the wild to have no restrictions whatsoever on which files users are allowed to upload. More commonly, developers implement what they believe to be robust validation that is either inherently flawed or can be easily bypassed. For example, they may attempt to blacklist dangerous file types but fail to account for parsing discrepancies when checking the file extensions. As with any blacklist, it's also easy to accidentally omit more obscure file types, and that may still be dangerous. In other cases, the website may attempt to check the file type by verifying properties that can be easily manipulated by an attacker using tools like burp proxy or repeater. Ultimately, even robust validation measures may be applied inconsistently across the network of hosts and the directories that form the website, resulting in discrepancies that can be exploited. How the How do web servers handle requests for static files? Before we look at how to exploit file upload vulnerabilities, it's important that you have a basic understanding of how um, servers handle requests for static files. Historically, websites consisted almost entirely of static files that would be served to users when requested. As a result, the path of each request could be mapped with the directions and the files of server file system. Nowadays, websites are increasingly dynamic, and the path of request often has no direct relationship to the file system at all. Nevertheless, web servers still deal with requests for some static files, including style sheets, images, and so on. The process for handling these static files is still largely the same. At some point, the server parses the path in the request to identify the file extension. It then uses this to determine the type of the file being requested, typically by comparing it to a list of pre-configured mappings between extensions. What happens next depends on the file type and the service configuration. If this file type is non-executable, such as an image or a static HTML page, the server may just send the file's content to the client in an HTTP response. If the type is executable, if the file type executable, such as PHP file, and the server is configured to execute files of these types, it will assign variables based on the headers and the parameters in the HTTP request before running the script. The resulting output may then be sent to the client in an HTTP response. If the file type is executable but the server is not configured to execute files of this type, it will generally respond with an error. However, in some cases, the contents of the file may still be served to the client as plain text. Such misconfigurations can occasionally be exploited to leak source code and another sensitive information. You can see an example of this our information disclosure learning materials. Later we will try to solve one example. There is some tip. The content type response header might provide clues as to what kind of file the server thinks as it has served. If his header hasn't been explicitly set by the application code, it normally contains the result of the file extensions type mapping.